Okay, the Demeter principle. This is one of my favorites, and this is the one that we decided to hijack the D in solid. Normally, the D is the one used for dependency injection, but Demeter, even though it's not part of the solid principles, it kind of fits in with them, and it actually is very common in Ruby and Rails applications, so we wanted to make sure to give it some attention. And you can summarize it basically as don't talk to strangers inappropriately. What this means in practice is when you have an object that you're calling methods on, you can call methods on the object itself. And if the object has its own instance variables, like that correspond to components of the object, like an engine being a component of a car, you can call methods on that because, if it's a component of you, then you should know what methods it has. But you should not rely on calling methods on the results returned by those things. And as always, we'll show you a code example, which makes it much easier to see. OK, here's a scenario that shows a really easy example. And I adapted this from somebody's blog. I had to do some translation, but thank you to Dan Manges. So we have a wallet, we have a customer, and a paperboy. And a wallet has cash, a customer has a wallet, and one of the paperboy's jobs is to collect money. And the collect money method has this check in it that checks the amount of cash in the customer's wallet. And this is where the Demeter violation is, because basically paperboy is twice removed from the thing that it's worrying about, right? Paperboy arguably knows something about the customer. That's a direct collaborator class. But it's making an assumption about the fact that the customer has a wallet and about what instance methods could be called on the wallet. So it's sort of reaching down through one of its own members to get information that it probably shouldn't have access to, right? It's hard to argue that paperboy is a collaborator of wallet, yet the way that we've written the method, they're actually bound together. A change in the wallet implementation could ripple all the way up to this class, paperboy, even though technically we're not supposed to be coupling between them. So how could you improve on this? Well, we've used delegation a lot, and one way to fix Demeter problems is to delegate your way out of them. And by the way, how can you tell when you're doing this? Imagine you tried to write a test for this code, and the key is that you're going to have, at some point in your test, you're going to execute this line, right? You're going to have a customer, and you're going to dereference the wallet, and then you're going to dereference cache. That means that in your test, you've got to mock the wallet and make sure that it can respond to the cache message. And in your customer, you've got to make sure that the customer has the mocked wallet. So this is the thing that we raised earlier called a mock train wreck, that just to execute a particular line of code, you end up having to do a chain of mocks. That's pretty much a surefire sign that you have a Demeter violation somewhere. So what could you do that would be better? Well, one thing we could do is if we want to try to make it the case that paperboy and customer are collaborators, but that the other things that customer is a collaborator of don't become coupled to paperboy, one thing we could do is in the customer, we could define a cache method that just delegates back to the wallet, right? So we've seen delegation before. It's basically exactly passing the buck to some other class that you collaborate with. But at least this interposes a layer of invariant between paperboy and wallet, because now I'm just talking about customer cache, right? So all references to the idea that the way a customer manages cache is through a wallet have now been excised from the paperboy class, so I've removed that dependency, right? And remember, what we're trying to do is minimize the number of dependencies we have between different classes. So this means that if the implementation of money changes, for example, maybe cash is no longer just something that's in a wallet, but there's also cash that could come from a credit account, then as long as the customer cache method is properly modified, nothing has to happen to paperboy, right? We're minimizing the cost of change, minimizing the number of things that are affected when we make a change. An even better thing to do is to delegate the entire behavior, right? So here we have, here's the same wallet, but now we've delegated the idea of withdrawing to the wallet, which is arguably where it belongs, right? The wallet is probably in the best position to tell you when it's empty or not. And now the customer just delegates the behavior all the way up to wallet. And paperboy doesn't really have to know about the implementation at all, right? So previously, looking at the difference between this version and the previous version, here we've delegated a behavior, right? We're still collaborating with customer, but the collaboration is in the form of asking the customer to do this behavior. In the previous solution, we're collaborating with customer, but the collaboration is more tightly bound to the idea that customer cache is a constant that we can manipulate and do things with, right? So this version makes more assumptions about the nature of the collaboration than this one does, because here all we've done is delegate the entire behavior. So ultimately, the bottom one is probably the cleanest solution to this. So there's more than one way to fix Demeter problems. Usually the most straightforward way is the one that I just showed. And if you look in the Fowler refactoring books, this is one of the canonical refactorings. It's called replace method with delegate. Right? Previously in Paperboy, we were calling a method. We replaced that with a call to a delegate that hides the fact that that method actually depends on something else. But there's other things that you can do as well to avoid scenarios where you end up with Demeter violations. One of them is a frequent source of Demeter violations is that you're mixing the traversal of a data structure with things that you can do on that data structure. In Ruby, this doesn't happen that often because things like iterators are such a part of the language's DNA that the idea of separating traversal and computation is already taken care of. So that flavor of Demeter violation is pretty rare in reasonable Ruby programs. But another one that actually occurs quite frequently is when you want to be aware of important events in another class, but you don't want to be tightly bound to that class. You don't want to depend on how the methods are implemented. You just want to know when something's happening. And that brings us to the motivation for another pattern called the observer. The problem this solves is that as an observer, I want to know when certain things happen to the subject, the thing I'm observing. And I have reasons of my own for why I might want to do that. As we'll see when we talk about caching, caching is a great example of this, right? Since you all have taken 61C, or most of you have taken 61C, and those of you on the internet who are familiar with caching, one of the problems that arises in caching is how do you know when to invalidate something that you have a cached copy of? And what you'd like to do is you'd like to know when the original value of that thing is changing out from under you so you can invalidate your copy. So you can imagine applying this to models. I might have a cached copy of some values from a model table, but I want to know when the model table might change in such a way that my cached copies might no longer be valid. That would be an example of when you would use observer. So in terms of a design diagram, we think of the subject as having a list of observers. The observer is essentially an abstract class that has an update method, and the subclasses of observer can use the update hook, in this case, to do whatever they want. So in this case, where we have an observer that is going to, we're subclassing the observer with a specific employee observer that wants to understand whenever a payroll table or something like that is updated. The update code in the subclass does whatever concrete things are supposed to happen when you observe the event. So, and by the way, if this looks like dependency injection, it is, right? We have the subject class depending on the API of the observer, which provides a specific set of hooks. And then whenever one of those hooks is triggered, it's actually a subclass that has a concrete implementation that takes it over. Other example use cases that come up in SaaS apps all the time, think about Craigslist, right? When you do a new post, there's actually a separate indexer that is the thing that's consulted when people search for keywords. So whenever a new post happens, you'd want to notify the indexer so that it can update its index. Another possibility is if your app does certain actions that are sensitive and you want to be able to audit those actions. So you don't want to modify the logic for the actions themselves, but when one of those actions is triggered, you want to take some additional steps, like create a separate audit log showing who did those actions. An example that arises in Rails is relational integrity. And here's, again, a real-life example from a system that I maintain. What happens if you've got a customer's made all kinds of transactions, like they bought a bunch of things, and now the customer wants to delete their account, like shut down my account information. We obviously can't delete the transactions they did because then the books wouldn't balance anymore. On the other hand, if we delete the customer, the transactions are going to have foreign keys that now point to a customer that doesn't exist anymore, right? That's a relational integrity violation. So what we would like to do is, or what I did is something that's kind of pretty similar to the null object. I have this special customer that is the unknown customer, like the unknown soldier or something. The unknown customer never shows up in listings, never shows up in reports, but it's the customer who owns everything that otherwise would have been orphaned. So what I really want to do is, whenever a customer wants to delete themselves, I need to grab all of the transactions that that customer did and now make them so that they're owned by this special unknown customer. So how do I do this? I create an observer class. Active Record gives us a base to build on that allows one model to observe another. And in fact, if I use their observer class, I don't even need to explicitly say who I'm observing because convention over configuration will figure it out. The fact that I called it customer observer means it's a thing that observes customers. And now what I can do is I can define, if you remember the active record lifecycle, there's specific points when a record is being edited or updated or deleted that you can interpose and take actions. Well, this is the same thing, only now the actions are occurring outside of the observed class. So what I'm saying is whenever a customer is destroyed, before the destroy actually finishes happening, call my before destroy method. And this is where I can put my logic that grabs all of the stuff that was previously tied to that customer and moves it over to be tied to the unknown customer instead. So that's a pretty simple example of an observer. And notice I didn't have to modify the customer class in place to do this, right? As you might imagine, what actually happens is that the active record lifecycle hooks are repurposed to actually send the observed call back to me. So this is a very nice example of I can observe a class without modifying the original class. Customer's implementation doesn't have to change in any way in order for me to be able to do this. And then just as a mechanical note, if you decide to use this, be aware that you also have to provide a list of which observers you're actually going to use in your app. But that's really just a mechanical detail. So here's a question about possibly trivial Demeter violations. Suppose we have a relationship like order belongs to customer. And in one of the views, there's an order variable that's been passed into the view. And you see this dereference, order.customer.name. Ooh, we're reaching down through 2 levels, right? Order knows about customers, but now it's also making assumptions about this attribute. So the question is this a Demeter violation? And your choices are technically yes, but in this case it's a reasonable one. It's one you're willing to live with, because the whole point of a view is to show information about models. So you're just exposing the object graph, not a big sin. You're not hardwiring this into the logic of your application anywhere. You might say technically yes, and if you're a purist, you could replace you could create a delegate method, customer name, let's say, that just delegates down to customer.name, kind of like we saw in the Demeter example, and that would fix it. You might say yes, and actually either of the above. Depending on your engineering taste and judgment, you could do either number 1 or number 2. Or you could disagree and think that, no, actually, this isn't really a Demeter violation, because just by having said that order belongs to customer, we're already exposing some information about the customer anyway. So no violation there. So which of these?